So 11.7 is on similar solids. Similar solids are two solids that have the same ratio of measurements. So the same ratio of measurements. So just as we did with similar polygons, we can do the same thing for similar solids. We're going to see if they have the same ratio of corresponding sides. So this one, let's go ahead and line this up. I'm going to take one of them and put smallest to biggest on the top. And then the other solid, smallest to biggest on bottom. And I'm going to see if we have a true statement. Are all these numbers the same? And you can either divide them into it but with a calculator or reduce the fractions. So 2 divided by 2 is 1. Are all of these the same? No, right? So these guys are not similar. Right? That one does not equal. So let's set up this next one, right, and see if these guys are similar. So now we have, in the same way, our small guy in the top, 2, 2, and 3. And then on the bottom, 4, 4, and 6. And if I reduce these, I get 1 over 2 equals 1 over 2 equals 1 over 2. Check. That's a true statement. So, yes, they are similar. Questions on that one? So our similar solids theorem. If two similar solids have a scale factor of A to B, then the corresponding areas have a ratio of A squared to B squared. That's their surface areas. And the corresponding volumes have a ratio of A to the third B squared. So not only with the we can use this for the surface areas, but we can also use it with the corresponding sides at A squared to B squared. All right, so how we can go ahead and use these. The boxes are similar with a scale factor of 1 to 3. Find the surface area and volume of box G if box F has a surface area and volume of 24 squared and 7 cubic feet. All right, so we want to find G if F has those. So F is the smaller one, right? And we have, so F is going to be on the top here. G is going to be here. So for the surface area, I'm going to square each of those. Okay? So I want to solve for G. I'm given F is 24. So now I simplify these over here and just cross multiply. So the surface area of the larger one, when I cross multiply, 1 times x, x, 9 times 24, 216. So the surface area of box G is 216 square feet. Now we can do the same thing with volume. Right? Again, I'm going to set it up the same way. So there's my F, there's my G, and want to do volume. So now I'm going to cube each of these. And on top, we're given this is 7. I'm going to solve that on the bottom. So I end up with 1 over 27 with 7 over 6. Cross multiply. X equals 189 cubic feet. And that is the volume of G. If X, or at the volume of G, if F at a volume of 7. The last problem we're set up. Find the scale factor of 2 similar shapes with volumes of 512, 1728. All right, so first what I want to do is reduce this fraction as low as it can go. Okay? And I'll show you one other method. So, remembering our divisibility rules, if this is divisible by 2, 512 divided by 2 is 256. So let's do a tree here. 256 divided by 2 again, 128 divided by 2 again, 64, 2 again, 32, 2 again, 16, 2 again, 8, 2 again, 4, 2, and 2. How many 2's do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9 2's. All right, now let's do 1728 and see where that ends up. So 1728. So 1728. Two times 864. 432. 216. 2 and 54. 2 and 27. And then this is 3. That's 3. That's 3. So how many 2's do we have? We have 3 3's, and then we have 1, 2, 3, 4, 5, 6. All right. So now I'm going to cancel out anything that matches on top and bottom, just like simplifying the fraction. I'm left with these guys, right? And since I'm given volumes, right, we need to take, essentially we're left with on top 8 over 27, right? And to find the scale factor, I need to take the cube root of those. So cube root, just like square roots, instead of just needing 2 pair, a match of 2 to come out, we need 3 that match to come out. So if we look here, taking the cube root of each of these, right? So just like our analogy, 2 will go away, and the scale factor 2 over 3. The cube root of the ratio of the volumes is going to be our scale factor. Let's take it one step further. What is going to be the ratio of the areas? Let's square each of those, right? So the surface areas are going to have a scale factor of 4 to 9. Questions on this so far? Could I just go ahead and, let's see in our calculator. So what if I took 512 and divided it by 1728, and then I took that to the cube root? I end up with 0.66667, right? Is that the same as 2/3?
Yes.
Yeah, so you can take the cube root of this if you divide it, and also find the scale factor with your calculator.